How do we define a partial differential equation? It is basically an equation having one or more partial derivatives of a function which has two or more variables, and such an equation is referred to as a partial differential equation. Now there are different kinds of problems you may get. The first one happens to be the formation of a partial differential equation by eliminating arbitrary constants. So to form a partial differential equation, first we consider an equation wherein you need to eliminate the arbitrary constants and obtain the partial differential equation. So let us consider a few examples. So we have an equation z equals x plus a into y plus b. Now I have to differentiate z partially with respect to x and z partially with respect to y. So therefore del z by del x equals, so I differentiate this partially with respect to x, so I get differential of x is 1, this is of course a constant, into y plus b. So this factor is treated as a constant, so you call this as equation 2 and we'll call this as equation 1. Now for simplicity, let me refer del z by del x as p. So this is p. So p equals del z by del x. Again, differentiating z partially with respect to y, we get del z by del y, which we are calling it as q, equals x plus a. So treat the first part as a constant into differential of y, which is 1. Call this as equation 3. So now substitute 2 and 3 in equation 1. So what is x plus a? It is q, which is del z by del y. And what is y plus b? It is del z by del x. So this is equal to p into q, or it is nothing but del z by del x into del z by del y. So this is the required partial differential equation. 2 ax square plus by square plus z square equals 1. So I have to differentiate the equation with respect to z. So what is z? Z square equals 1 minus ax square minus by square. So differentiating this expression partially with respect to x, so you have 2z del z by del x equals differential of 1 is 0 minus a into 2x, and this becomes 0 here. So 2 gets cancelled. So you have z, this is p, I'm calling del z by del x as p, equals minus ax, or what is a? A is minus zp by x. So let me call this as equation 1 and let me call this as equation 2. Now differentiating equation 1 partially with respect to y. So we have 2z del z by del y equals, the first two terms are 0, minus b to y. So 2 gets cancelled. So now let me represent del z by del y as q. So you have zq equals minus by, and what is b? It is nothing but minus zq by y. So now let us call this as 3. So let us substitute a and b in equation 1. So we get z square equals 1 minus a is minus zp by x into x square, and then you have minus b is minus zq by y into y square. So minus becomes plus, and one of the x gets cancelled. So you have z square, I bring this 1 to the other side, minus 1 equals zpx plus zqy, or z square minus 1 equals z into px plus qy. So this is the required partial differential equation. So next one, find the partial differential equation of a family of all spheres whose centers lie on the plane z equal to 0 and have a constant radius equal to r. So since the family of the spheres lie on the plane z equal to 0, we definitely have a value of z equal to 0 here, and let the value of x and y be a and b. So a and b are the constants. So we have the equation x minus a the whole square plus y minus b the whole square plus z square equals r square. Right? So now I need to form the partial differential equation. So let me call this as equation 1. Differentiate 1 partially with respect to x. So you get 2x minus a plus this becomes 0, 2z del z by del x equal to 0. So 2 gets cancelled. So you have x minus a equals minus z, and this is p. So I write this as p. So x minus a equals minus zp. Call this as equation 2. Again, partially differentiating 1 with respect to y. You have 2y minus b plus 2z del z by del y equal to 0. 2 gets cancelled. Del z by del y is q, right? So you take this to the right hand side. So you get y minus b equals minus zq. So you have equation 3. Now substitute 2 and 3 in equation 1. So x minus a is minus zp the whole square plus y minus b is minus zq the whole square plus z square equals r square. So you have z square p square plus z square q square plus z square equals r square. So z square can be taken common. So we have p square plus q square plus 1 equals r square, and this is the required partial differential equation. So the next problem, z equals xy plus y into root of x square minus y square plus b. So call this as equation 1. So I need to differentiate this partially with respect to x. So del z by del x equals, so y into partially differentiate x with respect to x, wherein you get 1 plus y into, now I need to differentiate this partially, so you get 1 by 2 root of x square minus a square into 2x plus 0. So 2 and 2 gets cancelled. So we have p equals y plus xy divided by root of x square minus a square. So call this as equation 2. Now differentiate equation 1 partially with respect to y. So you have del z by del y equals x plus root of x square minus a square into 1. Partially differentiate y with respect to y, you get 1, and this is equation 2. So del z by del y is q, which is equal to x plus root of x square minus a square. Call this as equation 3. So we have q minus x equals root of x square minus a square, right? So use this in equation 2. So we have p minus y, I bring this y to the other side, equals xy divided by root of x square minus a square, that is q minus x, right? So you have p minus y equals xy divided by q minus x. So multiply these two, so you get p minus y into q minus x equals xy. Now open the brackets. We have pq into p x with a minus sign, so it is px minus qy, and then you have plus xy equals xy. So xy gets cancelled. So you have pq equals, take these two terms to the other side, px plus qy. So this is the required partial differential equation. So like this you can solve a number of problems wherein you need to form the partial differential equation by eliminating the arbitrary constants. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.